So our next topic is um, a word, how it's take it and read it as in a memory. So on a memory registers records are three types: read, register in, out, memory address registers in and read, memory address registers in WMFC, then memory data registers out, and data in and out. Store a word as a memory address tendered into the memory address registers, and then data is to be written as a loaded in MDR, and then write the commands is issued. So move the issue forward to R2. Let us the registers in out and memory address registers R2 out and memory data registers right and memory data or registers out and WMFC. That is, the execution of a complete instruction is having the four stages. Fetch the instruction, fetch the instructions, and fetch the instructions, fetch the first operands, the content of the memory locations in R3 registers R3, perform the additions and unload read into the registers 1. So program counters and memory address registers read, select date address and jet in. That is, jet out is output and program counters, so in and WMFC. Memory data register fetch the instruction registers and the R3 memory address registers and read, and then R in and R out and WY in and WMFC. Memory data registers select all the jet in and the jet out or in and the end. Brand. Then next one is branch instruction is nothing but it's a branching instruction that jump and loop, and then here affects the field of out and the add and the instruction in and out. So here fetch the number of instruction is as a 0 and then increment into 1. So next one is a bus organization. So introduce the steps. It's having the processor to carry out the multiple indented path, that is it's having the execution in parallel and proper registration of that content into the register into file, and it's observed that the incremented PCs and the registers file, and it's calculate the given memory data registers and then print in a memory address registers. So say instructions to evaluate here. Here the clock signal is step into the clock control, and it's decode or encode the instructions in external locations and its process. Likewise, here the gate is explain the process of that particular registers. It's having the gate AND gate and OR gate to merge the process of that particular registers. Next one is block diagram of a complete processor. Here it's having the introduction unit, instruction set unit and integer unit, floating point data types. It's controlled by data cache and it's connected to the bus interface, which is implemented with the cache, and it's controlled through the instruction unit. And take the bus infrastructure and its transfer. It's not it's having the main memory and the input output return. It's a block diagram of a computer process. Then the mixer program to control is nothing but it's having the preprocessor and added the growth generation of a signals which is having to send the signals. having like the instruction first initiate from a 0 onwards, and the program counter increase the value of the addresses one by one. Its class is given as input and it's triggered to the particular process, and finally it's giving the output. Then pipelining.